Alright, so far in this chapter we've talked about how many ways something can happen. Well, now let's talk about the chance that something happens. So we're going to talk a little bit about probability in this section, which some of it will be review, some of it will be kind of new. So probability of something is represented as probability of the event. So E, again, is an event, which I'm going to get back to in a second. Well, probability of an event happening is the number of outcomes divided by the number of possible outcomes. Divided by the number of possible outcomes. So let's talk about what an event is. An event is a subset of a sample space, or what we want to happen, basically. So the sample space, then, going back, is a set of all possible outcomes. So those are the three things we can use interchangeably to figure out what the probability of something happening is. So on the terms, a probability complementary events means something can happen or it cannot happen. So usually we typically think of this as the event happening or the event not happening, which can also be E prime. Sometimes we see not E, or something like that. Those are different ways, or again, this means not E, so it doesn't happen. If E and the intersection of not E equals 0, then we call this mutually exclusive. So the two events don't interfere with each other. If the probability of event E plus the probability of the event not happening equals 1, that means one of two outcomes must happen. So think about this as flipping a coin flipping a coin and getting heads. The probability of heads is E. Not heads would be not E, so that would be tails. While E intersection not E equals 0, aka, or also, probability of flipping a heads plus the probability of flipping a tails equals 1. Those are the only two choices. All right, let me define that there's a not here. That equals 1. So one of the two outcomes has to happen. So again, those two are complementary events. So let's talk about an actual example here. We have a spinner with 8 congruent sectors numbered 1 through 8. The person spinning hopes to land on an even number. Alright, so what's the sample space? The sample space, again, is everything possible. So we have 1, 2, 3, 4, 5, 6, 7, 8. We can land on everything. What is the event happening? We want to land on an even number. That's the actual event. What are the outcomes in this event? That is 2, 4, 6, and 8. So those are the actual possible outcomes. Now we want the probability, so probability of E. I'm going to call E landing on an even number. So we need that the possible over total. So total possible is 4, and we have 8 options. So half is our chance. Well, now let's look at the next example here. What's the probability that it lands on a 2 or probability it lands on a 5? Well, what are those two events? Probability of 2, there's 1 total out of 8. Probability of 5, there's 1 total out of 8. So 1/8 plus 1/8 equals 2/8, which is 1/4. So that's the probability you land on either a 2 or a 5. Alright, so let's work on some more sample spaces here. Rolling a die. Okay, so you can get a 1, a 2, a 3, a 4, or a 5, or a 6. Drawing a marble from a bag containing 1 green, blue, and yellow. So we've got blue, green, and yellow. Drawing 2 marbles from a bag with 1 green, 1 blue, 1 yellow. In this case, we can get green and blue, we can get blue and yellow, and we can get green and yellow. The other way around, they're going to be the same type of thing. Answering a 3-question true-false test. Well, you can have true, all true, you can have all false, you can answer the first one true and the second 2 false, you can answer the first 2 true, the last 1 false, you can answer the first false, the last 2 true, the first 2 false, the last true, we can have the first true, the second false, the last true. So we got 1, 2, 3, 4, 5, 6, 7. And we can answer false, true, false. So we got 8 options there. And now segments joining A, B, C, and D, AB, AC, AD, BC, BD, and CD. Alright, so those are kind of sample spaces. Those should be pretty easy. For the most part, you don't ever have to list them. You just have to know them to do your actual problem. So the outcomes in the event. So let's talk about this. A digit from 0 to 9 is odd. So that's 1, 3, 5, 7, and 9. So I've got 1, 2, 3, 4, 5. 5 outcomes. Month beginning with J. We've got January, we've got June, we've got July. So there's 3 total. Less than 5 comes up, so 5 is not included. So I've got 4, 3, 2, and 1. So there's 4 options. Alright, so again, that's kind of just getting you to think about the outcomes. Let's do some actual probability here. So find the probability if you roll a die, it results in each event. Express your answer as a fraction. So rolling a 4. So probability of a 4 is 1 over how many options? Well, rolling a die has 6 total options. So 1/6. If you do not roll a 2 or 3, so that means that you roll a 1, a 4, a 5, or a 6. So the probability that you do that is 4 total options out of 6, or 2/3. This is what we call a complement. So we could also do 1 minus the probability of rolling a 2 or a 3, which is 1 minus, 1 minus 2/6, which again will get you back there. Rolling an odd number, we've got 1, 3, and 5, 3 total options, so 3 out of 6 equals 1/2. Well, you can never roll an 8, so it's 1 over 1, so 1. Less than 5, we talked about this already. Less than 5, how many options do we have? We have 4 total. So less than 5 is 4 total out of 6, or 2/3 again. Alright, so moving on. Here's another example we have. 8 sophomores, 10 juniors, 6 seniors in one English class. One student's randomly chosen to first give a report. What's the probability of the event? So we want to find our total first. So 8, 10, 6. 8 plus 10 plus 6, 24 total. Right? So I want you to actually try this one and bring that to class to finish so we can talk about that. And let's move on to the next type of problem. So probability has a rule that we call the addition rule. So what is that? That is the probability of an event. So probability, when 2 events are united together, it means that we take the probability of event A and we add it to probability of event B. But we need to subtract out the intersection of those 2 events. So this is when both happen at the same time. Alright, and we read this as P of A or B, which we've seen some events of. Now, one thing you want to note here is P of A intersection B equals 0 when mutually exclusive. Alright, so let's talk about an example. Central angles of a spinner have 2 red sectors that measure 34 degrees and 48 degrees. So find the probability that we land on red. So event is land on red. So since there's 2 different red sectors, I need the probability of red 1 plus the probability of red 2. I need to subtract out the probability of the intersection of red 1 and red 2. Well, this actually can't happen. Can't land in both red. So again, this is mutually exclusive because the 2 reds don't end up on each other. Well, what's the probability I end up on red 1? So we're going to consider 34 degrees red 1. Since it's a circle, we're going to do 34 degrees out of 360 plus 48 degrees out of 360. Subtract out 0. So that equals, we have 82 out of 360, which really ends up being 41 out of 180, or 0.227 repeating. Depending on how the answer is asked, that's how you would give it. In this case, usually you're going to want fractions. And we can turn that into a percentage if we wanted. 22% chance that you will land on one of the red sectors. Alright, moving on. At UIC, 60% of students are commuters, 50% are female, and 30% are female commuters. So, selecting at random, what is the probability that a student is either female or a commuter? So, probability of female or commuter. So, we have to add up the probability of being female plus the probability of a commuter, but we need to subtract out the probability that they're a female commuter. So 60%, or how many percent are female? 50, so 0.5, plus the commuters, 0.6, and we're going to subtract out the female commuters, 0.3. Alright, and we get a grand total here of 0.8, which equals 80%. So again, that's kind of the addition rule. When events kind of overlap, you have to consider subtracting out that overlap. One more topic here is odds. Odds and probability are not the same thing. So odds does not equal probability. So what are odds? Odds can be either in favor or we can have odds against. So, odds in favor are by doing the probability of something happening to the probability of something not happening. Odds against are the probability of the event not happening to the probability of the event happening. So they're just the reverses of each other. So think about this as A to B. So then probability is going to be A over A plus B. So again, this equals the probability of the event happening. Well, the reverse is true. B to A gives us B over A plus B, equaling the probability of the event not happening. I know that doesn't make total sense right now, but let's apply it and it will make sense a lot more. So, if the probability is 2/3 that the Bears will win the Super Bowl, then what are the odds that they win? So remember, probability is that they win, so P of win, 2, and we want the odds in favor, so the odds, to the probability that they lose. So winning is 2/3, losing would be 1/3, since those two events go together. Since I have 3 and 3, those can go away, so the odds in favor are 2 to 1. What are the odds against? Again, that would be the opposite. That would be probability of losing to the probability of winning, or just the reverse. So odds against are 1 to 2. The last situation is going to be using this part here. So odds in favor of C Biscuit winning the races are 4 to 1. So 4 to 1 are my odds. What is the probability that C Biscuit wins the race? So since it's in favor, we know we have A to B, which means my odds are 4 out of A plus B, which is 4 over 4 plus 1. I have a 4/5 chance. So the probability of winning is a 4/5 chance. Alright, so those are all the notes you need for probability. Now come to class, we'll discuss that you try problem, and then the rest of time will be spent on making sure we know how to do these problems for the test next Friday.